Dobry wieczór. Była godzina 6. Rozpocznijmy. A miałem mówić po angielsku, so I will switch to English then and I will start again. So welcome back to 30-second Wro.cpp meetup. Today we have excellent speaker Tomasz, who will give you some tips regarding really cool technology. But let's go through my presentation first as an introduction to keep the tradition alive. So, as a reminder, we made a goal for those meetings to make you guys successful as C++ specialists. I created a couple of topics that I think we should cover, or any of the C++ specialists or experts should know to be able to be efficient in any C++ project. If you did not yet provide an input from regarding the technology or your point of view regarding what is important for you when it comes to C++ and technologies around it, please go and share your thoughts here. The agenda for today, as I already mentioned, there is a Tomasz. Watch out, Tomasz! I will share your face. So there is a Tomasz, and Tomasz will tell you about GStreamer multimedia framework. So in a second, I will give him a stage, but now I will hide you again. So this is the plan. Only one presentation today, but I hope it will be a great presentation. Please share your appreciation to our initiative on our channels. Go subscribe, share with your friends, and any voice or recommendation or like is a benefit for us. We can reach more people thanks to you guys, so do not hesitate to do it. We have also a web page on the GitHub.io. Do not hesitate to go there, and if you can help me in keeping it up to date, just let me know. We'll appreciate any help regarding keeping it alive. We have also a Patronite, so if you want to support us financially, you can do it via the Patronite. So just go there and check what options do you have there. And we have a Platinum patron, Adam Badura. I promised him that for all his contributions to our initiative, I will be putting him on all my material. So I'm doing that right now. So thanks, Adam, once again for your contributions. And yeah, so that's it from my side. So I would stop talking. I will give space for Tomasz. So Tomek, please share your presentation. I will move it here and show it to everybody.
Okay, one second.
Okay. Okay, now, yeah.
Okay, is it visible?
Yes, I see it at least. Guys, can you see it? Can you hear us well? Just let us know now. It will be a waste if we will be talking and nobody will see it or hear it. So just let us know if everything works as expected. So let's wait for a second for your responses, and we will start. Just let us know. You just need to write a comment on the YouTube. Thank you, Leszek, for letting us know. Thank you. So we will then start. So Tomasz, the floor is yours. have a good presentation. I will be watching you from backstage.
Okay, thank you very much. Hi guys, my name is Tomasz Mikołajczyk. I would like to talk today about GStreamer multimedia framework. It will be rather a kind of introduction to the tool, to the framework, and to the concepts behind that. I will show some examples, how it works, and some code as well, and give you some my subjective opinion about the tool. I hope that you find it useful and helpful. So who am I? I'm a software developer, software consultant, sometimes freelancer as well. I started my professional career in 2004. My background is electronics. And during that time, since 2004, I was working various domains, in various companies in Wrocław or remotely. For recent years, I'm cooperating with startups and I'm concentrating on computer vision, video processing, and always C++ as the core technology. Apart from C++, also C, some Python, some Objective-C, Go. I'm learning Rust right now. I also touch some JavaScript. After hours or programming is not my only hobby. I'm also teaching kids mathematics and programming. I have a group of kids that I teach daily. Also, I'm a musician playing guitar in my band together with my friends. There is a profile, my LinkedIn profile. It's not up to date, but anyway. And I'm from Głuchołazy. That's the city you probably all know about because of the recent flood. This is from the image from the September. You can see my parents' apartment there. They are safe, but the situation in the city is still horrible. So what is GStreamer? GStreamer is a framework for creating some kind of media related applications. It processes media data from files, from streams, from just the bytes of the multimedia data. It offers a set of reusable building blocks, which could be used to construct a multimedia pipeline containing some encoders, decoders, maxers, demaxers, filters, transcoders. They are linked together to create a pipeline which process the multimedia as you want, whatever you want to achieve. It supports very wide variety of media formats, and they claim that they have more than 1,000 elements, so 1,000 building blocks that you can build your media pipelines from. You may build kind of video players, media players, transcoders, streamers. There are some big players using GStreamer nowadays. One of it is NVIDIA, Netflix, all big TV broadcasters, and also I know that Unity is looking into integrating their playback stuff on top of GStreamer. It supports Linux. It's supported on Linux, Windows, all the major platforms, including the mobile app. And the project is pretty old. It has been started in 1999, basically, so 25 years ago, more or less. And since that time, it evolved a lot. It's still being actively developed by a group of experts, group of people that most of them work for a long time there. On this picture, I took this picture from the GStreamer documentation. It shows the concept. So there is a core part of that framework, which defines some kind of interfaces that plugins doing some particular work implement. There are well-defined interactions between these plugins. I will talk about that shortly. And there are, as I said, more than 1,000 elements already written, available for free. And and that there are also tools built on top of that core part. There are some GStreamer utility applications. We'll talk about that. And with that tools, you can build your own multimedia pipelines, whatever you want. Before we go talking about the GStreamer, I would like to make sure that we all are aware what are the typical multimedia formats, what is the media container, and what it can contain, and because that's the core concept that the pipeline operates on. So by multimedia, I mean it could be audio file, video file, or audio video file. It could be images, subtitles. It could be interaction with some kind of hardware, some kind of devices like camera devices, audio devices. It could be online streaming, or it could be even a depth camera, because there are some also concepts how to transfer the depth information about depth from the camera with GStreamer. Also some standards for that as well. So media container is a kind of box which contains streams inside. It could the basic example is like video stream and audio stream, MP4 for example, but there could be just the video stream, just the audio stream inside, or multiple audio streams. It could contain also subtitles for various languages inside, or multimedia could be also just the video stream without any container. It could be raw video, it could be compressed video, whatever, or audio or image. And media container, apart from containing these streams, AV streams, it contains also some kind of additional information about the streams. For example, it can contain information about duration of the stream. It could contain information about the codecs that stream use, and so on. And there are multiple formats of the containers. The most popular that you probably know is MP4 or QuickTime on Apple devices. There is also Matroska. WebM is very web-oriented container. MPEG-TS is also for streaming. Old AVI or OGG. They are just contain various audio and video streams inside. And important concept here is maxer and demaxer. These are the components which also exist in GStreamer. So maxer is a kind of utility that combines audio and video streams into a container. So on the input, it contains either raw or encoded streams, audio or video, or subtitles as well. And on the output, it contains a container data, for example, MP4. And the demaxer is the opposite. So the demaxer splits a container into audio and video streams. Yes. What are the example audio formats? It could be uncompressed, the raw. I also mentioned here in how GStreamer marks that raw audio is audio/xraw. The audio could be compressed with various codecs, AAC, MP3, very popular, Vorbis, Opus. Opus is also web-based. What are the typical properties of the audio? It is the number of channels, the layout of the channels, how the sample in the channels are represented. So it could be interleaved or non-interleaved. On the right, there is this image. The top image is the interleaved. So the information about the channels are next to the other. And the non-interleave is not very typical, not very common format, I would say. So first of all, there is information about one channel, then there are information about the second channel. It's difficult to stream this kind of audio. So that's why probably it's not so common. Sample rate, the bit rate, and various formats. Formats means what kind of plain data is used for representing the values of the samples. and it could be doubles, floating points, integers, 32 bits, 16 bits, and so on. Example video formats, also uncompressed or compressed from the typical encoders. It is VP8, VP9 for Chromium, for Google, very common. MPEG 2, MPEG 4, H.264, H.265, also very popular. AV1, the modern one. Theora is quite pretty old nowadays. And example properties of the video formats is resolution of the video, the frame rate, so how many frames are in the per 1 second of the video, pixel aspect ratio, bit rate or color space. And on these pictures there is an example color spaces. So at the top there is a RGB, could be also BGR, RGBA, and so on. And below is at the bottom there is a UF240. This is also very popular because it saves some kind of space of the data and without decreasing the quality of the video. What are the encoders, decoders, and transponders? So audio decoder basically decodes the audio. So on the input there is an encoded audio, and the output there is a raw audio. The same for video. Video decoder decodes the video, so it just decodes the input to the raw video at the output. The encoder is the opposite, so it on the video and audio, on the input there is a uncompressed stream, and output is the compressed stream. And the transcoders is basically changing the decoders. Changing the encoders. So there is a video or audio encoded with one format, and on the input and on the output there is a video or audio encoded with the different format. And usually encoders and decoders, it is good if they use hardware acceleration, because such pipeline is way faster. It does not run on a CPU but on a dedicated hardware, and it is important to have hardware accelerators, because you may achieve way better, way more things done without. I don't have any particular numbers for that, but if you are doing some serious video processing, you cannot achieve more a lot without the hardware accelerators. Especially today with the AI algorithms and machine learning. This is the very basic multimedia pipeline, just the concept. So the input is a multimedia file, which first of all is processed by the demaxer. As I mentioned before, the main role of the demaxer is to split the container into streams. So there could be one audio stream or one video stream. Then each stream is processed separately by separate branches. So encoded audio goes to the decoder, encoded video goes to the decoder, and on the output there is a uncompressed raw audio and uncompressed raw video, using different formats depending on whatever was inside, or whatever the actually decoder selects. And there could be some kind of converter. Audio converter basically converts the internal representation of the samples. So it could be from double to floating points, for example, and then for the video converter, they just convert the color spaces. And at the end, for audio, there is a speaker that you can listen to the music, and for the video, there is a monitor that you can see the video stream. And such pipeline could be treated as a acyclic and directed graph. So we are going, that's the end of the, let's say, basic concepts of the multimedia. We go towards GStreamer concepts and kind of terminology that it's important to understand to work with GStreamer. It's mentioned here, but we'll be talking about that on the next slides. I will explain more. So the basic brick of GStreamer are elements. So element is a, let's say, small part which does something special to the stream. For example, encodes raw stream to the encodes video stream to some kind of H.264 format, for example. So an example of element will be H.264 encoder. Element typically has one sync path and one source path. What is sync and what is source? This is like entry and exit from the element. So there are that data flowing into the element through the sync path, and element produce data, multimedia data, which is available on source path. There could be elements with two inputs or two sync paths and one source path, or one sync path and multiple source path. For multiple inputs, an example of that is a maxer. So maxer contains multiple streams on input and produces just one output. And demaxer is the opposite, or also a T element. This is I skip that for now. And elements can be linked together. So basically, linking means connecting source to sync paths. And there could be different type of paths. There are some elements which have always sync and source path. For example, video encoder. There are some elements which may, but does not need to have any path, or demaxer, depending on number of the inputs. These paths are created or not automatically, and also there are elements which does not have any path unless requested. So an example is a T. T is a kind of multiplexer which multiplex the input to an output. So every output contains the same data. Multiplicator or something like that. Elements linked together could be enclosed to something called bin. So bin is a wrapper for linked elements, and bin has also defined sync path and source path. It could be any number of sync paths and number of source paths. And these bins could be also later used as a kind of one element without knowing what is inside. So encapsulation, basically. And the pipeline in GStreamer is a top bin element. So this is also an element. It is also a bin, but it contains everything linked together properly. And it also has assigned the clock, which calculates the current clock and the position of the timeline. And also it has assigned the bus. I will talk soon what is the bus about. The plugins. GStreamer plugins is a kind of set of shared library which contains written elements, and these libraries are loaded at on demand at real time, depending on what elements your pipeline used. As I said, this is important that these are shared libraries, and also there is a kind of cache which contains basic information what element sits in what shared library, more or less. Yeah, an example, there is also an example of the code of the bin. The very popular one is decode bin. So this is a bin, which is a kind of dynamic. So what it does, it detects automatically what kind of multimedia data is on input. It builds internal structure of this pipeline sitting inside the bin, depending on what is the input. And the purpose of that is to demax the input and decode the input. So on the output there is basically raw streams, as many as inside the container, or as many as you want. You can limit that as well. Elements in GStreamer contains have some properties, and you can think about that like element is a C++ class or structure, and property is a C++ class member variable. So you may read that variable, you may modify that variable, and this variable basically controls the behavior of the elements. So, for example, there is a element which generates a kind of test video data. So you may there are predefined video content. It could be a ball moving on the screen, or it could be something else, some kind of noise generated. So by you may control what this video test source generates by modifying some kind of variable dedicated to that. And as I said, some of them are readable, some of them are writable as well. Before the pipeline starts playing playing or processing the data, the elements which belongs to the pipeline needs to negotiate the exact formats of the data that will be flowing through the pipeline. This is called negotiation of the capabilities. Every element defines what it expects on the input and what it can generate on the output. It doesn't need to be one particular format. It could be a set of possibilities. And capabilities negotiation means that these elements talk to each other and deciding what the final format will be. It may happen that the pipeline is wrongly constructed and the elements cannot negotiate, the negotiation fails. So such pipeline is not playable at all. So you need to fix the pipeline, basically. So negotiation could be understood as finding intersection of the capabilities from all of the elements. And one more concept is the downstream and upstream direction. So on this picture, I showed what it means. So if there is a simple pipeline, the downstream direction is from the beginning to the end, and the upstream direction is from the end to the beginning. And this concept is very common in GStreamer, and it exists in various documentation, various places. So it's good to understand that. And audio and video converters usually helps in negotiation because it can adjust the input to the output, which is expected by downstream element in the pipeline. They exist very often in the pipelines. There are some tools provided by GStreamer, which is kind of which describe the elements. They show what elements can do, what are the properties, what are the capabilities of the element. And here's the example. There is a H.264 encoder, which on the input expects the raw video. This is the sync pad. Sync is an input of the element, and source the output of the element. And this encoder on the output produce the encoded video with the H.264 encoder. It can on the input expect any frame rate, any resolution of the video, and the output resolution is exactly the same. GST inspect is the tool that you can use to search for the elements that you would like to use, and search for the properties of the elements and the basic information what the element does. And here's an example, very simple pipeline which generates and render a video. So there is another tool, very powerful tool from GStreamer. It is called GST Launch. And basically this is a kind of tool which understands whatever is written on the command line treats it as a kind of textual representation of the pipeline graph. There are some rules, basic rules. So, for example, it cannot use pipe because it's on Linux. It's like used for something else. So they use the exclamation mark as a separation between the elements. So it means that there is a video test source element which talks to the audio video sync. So video test source is a component which generates a test video as an uncompressed video, and auto video sync is a element which can display raw video. And this is a kind of auto video sync depends on the particular system. So the implementation is system dependent. On macOS, it uses some other functionality to display the window. On Windows, different one, on Linux, different one, and so on. And if I would run that pipeline, I should expect something like this picture at the bottom. And perhaps I will try to show you. So GST launch, video test source linked with auto video sync. That's the window produced. I showed you about GST inspect. You can read about the properties of the elements, and for example, there is a pattern property, and I can set some numbers, which means different patterns. So I was using SMPTE, default one. I can use different one. So I can set a property of that video test source. I will use that. And then it just generates the ball moving on the screen. There is another example of the pipeline, a bit more complex. This is a pipeline which generates a WebM container having inside the VP8 encoded video and Opus encoded audio. And the such generated container is then saved to the file. So there is this video test source element which generates the test video data, audio test source which generates test audio data. Raw video goes to the encoder, VP8 encoder, raw audio goes to the Opus encoder. And from the encoder, there is an encoded video with an encoded audio from the Opus encoder. They goes to the maxer. I'm using here WebM maxer, and the WebM maxer produce the container data, which I have linked WebM maxer to the file sync, which basically saves the input to the file. And there is a pipeline, how it looks on the CLI. GST launch tool, as I said, it runs the pipeline, textual representation of the pipeline. So that's exactly what I mentioned on this picture here. And the way how we do it is we define the maxer and we assign some name to that. It can be any particular string, and then we are referring to that maxer by the string itself. So the maxer is linked with the file sync, and then there is a video test source element which is linked to the VP8 encoder, and then it's linked to the maxer. The syntax here is that there is a name and dot at the end. And this is the video branch, and at the bottom there is audio branch. So audio test source linked with the Opus encoder, and Opus encoder is linked with the maxer as well. And here as well, I'm referring to maxer by using its name with the dot at the end. And such pipeline generates the output.webm file, because I set that property of the file sync location, which is the name of the file. And on the right, there is another tool from GStreamer called GST Discoverer. So it basically discovers whatever is inside the multimedia file and presents on the screen. This is a CLI command as well. CLI tool. I'm not sure whether you want me to run it. I can try. What was that? Weapon max. I have it here. More or less. So there is a WebM maxer linked with file sync. I will be producing output WebM, and there is a video source linked to the encoder and maxer, and there is another branch audio test source linked to the Opus encoder and to the maxer. And it is important to also use the -e at the beginning, because it will be running as long as I don't press the Ctrl+C, as I don't stop. And without -e, it will terminate the pipeline not gracefully. So the produced container will be corrupted. And -e means that whenever I press the Ctrl+C, there is a graceful shutdown of the pipeline. So there is an end of stream signal sent to the pipeline. So pipeline knows that there won't be any more data, and it just saves the container, which is not non-corrupted then. So I just generated 22 seconds of the video, and you can see that there is this output WebM. I can use GST Discoverer to see what is inside. Yeah, there is a 23 seconds video, audio video. There is a container WebM having video stream and having audio stream. Video is VP8, audio is Opus encoded, and some basic information: one channel, sample rate, resolution, and so on. I can play it with another tool called GST Play. There is also audio that probably you don't hear, but there is. And I think that I have one more pipeline, even more complex. So seriously, these pipelines are not complex. When you write a multimedia application, they are the pipelines are really complicated and long. So here I'm using that generated output WebM as the source of the data, and I'm connecting that to the Matroska demaxer, because I know that this is WebM, so I can demax WebM with the Matroska demaxer. I just know that. And then Matroska demaxer produce the audio branch and the video branch. Audio branch, I'm queuing the frames, because it is important, because otherwise the pipeline would just block. I will talk about that shortly. And the video from the top queue, this queue for the video frames, goes to the decoder and to the auto video sync, and the frames from the audio queue goes to the Opus decoder, then goes to the volume. I just want to decrease the volume of the audio, and then play render in the speaker. And that's the pipeline, CLI pipeline, just below that image. So that's exactly representation of that CLI representation of that picture. And here I used Matroska demaxer plus Qs plus VP8 decoder and Opus decoder, and I could achieve exactly the same using the decode bin. I mentioned that tool already before. So decode bin is a kind of very automatic element which adjusts the pipeline depending on what is on the input. As I mentioned before, that whatever is on the input, it just demax that and decodes that. So there is the pipeline is at the bottom. So this is the equivalent of the picture. And I also use that technique of naming the element. So here the file source, and I'm reading the location property is set to output.webm, and I have linked that file source to decode bin, and I assigned a name for the decode bin. The name is D, and then I'm referring to the decode bin using its name. So D is linked with the auto video sync, and also this linked, that's the video branch, and the audio branch is linked with the volume, and I'm setting the volume to some low value, and then render to the sync, to the audio sync. Yes. Sorry.
Yeah, so maybe small hint to just press the height on the right of that small window.
Again?
So there's a height, you can just press it and it will just disappear.
Okay, thanks. Haven't seen that before. So decode provides some kind of automation. It detects the type of the input. There is a utility in GStreamer type finder. It basically needs just a couple of bytes on the input, and based on this bytes, it detects what is the structure of the input, and it provides the information with the what probability. This is MP4 with probability, for example, 100, or this is WebM with probability 99. It means that the probability will increase if there is more data on the input, more or less. And depending on the type of the input, it creates the dynamically the structure of the bin inside. So it creates the appropriate decoders, appropriate the multiplexer, and links everything together appropriately as well. So we were using this GST launch, but this tool has a kind of limits. It's not possible to achieve everything with the command line interface like that. It is really great if you are looking for some kind of if you are experimenting with the pipeline, whether it will work or not. And it works pretty well with the static pipelines. But there is a lot of things that usually you want to do in your multimedia application, but you cannot achieve that with the GST launch. So there is a way to do it. We can write the pipelines programmatically, because GStreamer is a framework with a set of libraries and the interfaces, well-defined interfaces. And by operating on these interfaces, we can build the pipeline programmatically. And also, it is possible to parse, to define kind of subset, or perhaps even entire pipeline as a kind of textual representation of the graph, pipeline graph, and then parse it programmatically and decorate with whatever you want there. So the next slides are about what would you like usually to do, but it's not possible with the GST launch. So this is upsource and upsync are, to me, very useful elements, which allows you to pass some in-memory bytes that you already have in memory to the pipeline, and also to consume the pipeline produced data and save it to memory and process further. For example, I can imagine that there is some kind of data which you read from the internet, from the socket, and you have all this data in memory, and you may just pass that memory to the GStreamer for further processing. And the pipeline generates some kind of output, I don't know, HLS segment, for example, and you would like to stream that segment directly to the browser through the socket. So there is no need to touch the file system at all with that elements. So they operate in chunks. So there are also two modes that app source may operate in. This is a push mode and pull mode. So perhaps basically in the push mode, the application push the data whenever it wants to, but the pushing may be blocked if there are if the pipeline is full of data, basically. Another mode is the pull mode. So the pipeline knows when it is ready to process next data, and it asks for. It's all with using kind of callbacks. mechanism and asynchronous processing. And the data pushed to the pipeline and read from the pipeline usually is with GStreamer buffers. This is a kind of small objects of with well-defined interface, and you may also want to use a kind of buffer pools just to save the memory when processing your pipeline. All of that is available only if you are working with the pipeline programmatically, not from the CLI. Element signals. So element, apart from having the properties I mentioned before, they define also kind of signals, which means there are asynchronous callbacks to notify application about some condition that happened to the element. For example, there is a HLS sync element in GStreamer which generates the HLS segments based on from the input multimedia, and in a typical mode, these segments are stored on the local file system as a files, and there is also this playlist manifest file which then you can load from your browser and play the video as YouTube does. YouTube does this kind of HLS streaming. So there is no entire video fetched to the browser, but there are video divided into the small chunks, and the browser receives the chunks in the meantime once while playing another segments. So HLS sync has a signal which is executed, or the callback, which is executed every time a new segment is produced, and you may do something with it instead of saving it to the file system. And another example is the app source. App source in the pull mode, as I mentioned, so the pipeline knows when it is ready to process more data. So it basically calls the callback registered before, called needs more data, and that callback needs to push in the reaction, push more data to the pipeline. Another callback is enough data. So if there is enough data and the pipeline has what to do, then this callback is called to stop pushing data to the pipeline. And these callbacks are called signals in GStreamer. And when you launch this GST inspect, you can read about these signals in the output of the tool. There is on the right side of the screen, this is an example of the GST inspect from the app source. So there are need data, enough data, and seek data signals. And there are signature of the callbacks itself. Yeah, more or less. Probes, signals. You cannot register your signals if you are dealing with CLI interface only of GStreamer. You need to operate on your pipeline in a programmatic way. And the same with probes. Probes notifies the application about the state of data flow. So this is a kind of I put a magnifier here on the screen, which is able to inspect the data or another information flying through the paths. So in practice, it means that you are registering a callback. So there is a function pointer stored somewhere in the element, and whenever there is a data flowing through the path, this callback is being called, and you may inspect this data. You may even modify that memory. You may drop some buffers, drop that data. You may also block. So for example, whenever there is, you may register a probe of the source path of the element. And whenever there is a first data passing the source path, there is this callback called, and that callback may block the entire pipeline because, for example, you would like to relink the downstream part of the pipeline. So it is important to relink that downstream part of the pipeline without having any data inside. So you are just blocking data at the very entry level, do some stuff to your pipeline, and then unblock it. Very useful stuff. widely used for debugging purposes, for investigating various investigations, or just for the pipeline relinking. That's what the code bin does, for example, in order to build the proper part of pipeline, depending on what is on the input. There are also some kind of messages, events, and queries. What's the difference? Messages are the, let's say, information flying between the application and the elements. They are asynchronous, so usually elements may notify application about some kind of event, some condition. For example, that the last buffer has been processed and there is no more, so there is an end of stream message. So application knows that pipeline finished the work. There could be some message indicating some error, warning, info about seeking. I will talk about seeking shortly. And the important thing is that this informations are asynchronous, and they are processed by the bus. Bus is a kind of concept in GStreamer, which usually means that there is a kind of thread reading information from the bus and dispatching. Very basic concept. Events in GStreamer are also kind of information and which are exchanged between the elements itself. So or only from the application to the element. So for example, application, whenever your pipeline, whenever you pushed the last part of the multimedia data, you just notify the pipeline sending the event that there is no more. And elements exchange the events between themselves, for example, to negotiate the capabilities, to share the information that there will be a seek of the pipeline. So there will be a seeking means moving forward or backward the stream. And there are also queries. Queries are, let's say, questions to the pipeline about something. Typical query is what is the duration of the pipeline, what is the current position the pipeline is at the moment, and the answer are always synchronous. So you ask for that and wait for the answer, blocking the thread. You cannot do anything to messages, events, and queries if you are working with CLI tool. Segment and seeking, as I mentioned before, segment is a part of the stream which contains start and stop. And if you have the pipeline, you may start playing the pipeline from any point in time you want, backward or forward. Once the final point is reached, you may jump to another part of the video. You may play backward. You may change the speed of the playback and so on. You may loop the pipeline. It also supports gapless playback with some dedicated events. So whenever you are about to reach the final step, you are notified about that with the message, I think, that the seek is done, and then you may prepare the next portion of the file that you will be seeking to and playing from. Very useful tool. A couple of questions, a couple of utilities which helps in working with GStreamer, in investigating, inspecting, and so on. GStreamer is integrated with Graphis. So as I mentioned, the pipeline is a graph. So it could be visualized as a graph and with Graphis. So there is a environment variable that you may set before launching your pipeline. It will be even CLI. It could be either CLI or just your application. So when you have the pipeline written programmatically, so you just set the location where the dot files will be saved. So as an outcome of that first line, the pipeline works as usual, but apart from doing whatever it does, it also generates the dot files, which are the Graphis compatible files, for each stage of the pipeline. And then you may generate, for example, PNG out of that. and have detailed information how your pipeline looks like, what are the inputs negotiated, what are the outputs negotiated, and so on. Here is the example. This is the first image. The first picture is the entire pipeline of the command line as on the above. The top command line generates some pipeline which is represented via this graph, and some kind of part of that. So you may see that there is a VP8 decoder, and on the input there is a VP8 stream, and on the output there is a raw video stream, and you may see what is the resolution on the input, on the output, what are the formats, some details, the pixel aspect ratio, and so on. And the same for audio. And there is Opus decoder. On the input there is Opus stream. On the output there is a raw audio, and all of the details that you may all the details about the format of the audio. There is also very useful tools related to logging, tracing, debugging. Some kind of mechanism of setting the logging level, severity, and so on through the variables, and you may. There is a lot of information if you are set the debug to level 7 or 8. There are even each buffer is dumped as a hexadecimal values of the bytes inside, and you can inspect whatever is flying through your pipeline. There are some kind of utilities for analyzing the statistics of the pipeline or tracing. So you may set some variables which will produce the information about the about memory usage, about some kind of statistic of the pipeline, and then use the GStStats utility, which would display the summary of that. So you would know, for example, number of the input buffers that were pushed to your pipeline, number of the buffers generated by your pipeline, all kind of low-level statistics which may sometimes save your life when you work with the GStreamer framework. So there's the summary of the tools that we talked about. GStInspect, this is the tool about related to reading information about the elements, what are the properties, what are the signals, what the element does, and what are the capabilities on the input, what are the capabilities on the output for the negotiation, and so on. GStLaunch is the tool that you may use to launch your CLI, text representation of the pipelines. Discoverer, displaying basic information about the structure of the containers, about the streams and so on, by reading the file content. GStPlay is a simple player, also very dynamic, so it builds the pipeline automatically based on whatever format you would like to play. So it analyzes the content of the file and adjusts to that by building the appropriate pipeline. GStStats, I just mentioned, is about tracing, and GStValidate is a kind of pipeline sanitizer. So you may detect some kind of errors that you have in the pipeline. Usually, if you deal with the command line, with the pipeline programmatically, there is a lot of mistakes that you can make, and it will show you. Or, yeah, it will tell you about that. Apart from GStreamer itself, there is something called GStreamer editing services. This is yet another beast. When first time I encountered that, it was pretty hidden in the documentation, but it happened that there is really a lot of stuff there and really useful stuff and badly documented. So this is a kind of, let's say, layer above GStreamer, which allows you to create some kind of media editing applications. So think about that this is a kind of equivalent of DaVinci Resolve tool or Wondershare Filmora tool. So with that, you may build equivalent of that. And what it means that basically the tool or the framework elements allows you to compose the video together, put some overlays on top of that, define some kind of transitions between the video files or audio files. You can have multiple video, multiple audio, and you define how the final video should look like. And then just render the input to the requested output. And there is a concept of this nonlinear elements. I put it here on the slide because it was difficult for me at the beginning to understand what is the concept behind, what is nonlinear elements. And this is the terminology from the movie production. So in the past, when people created a movie, they just cut the scene into smaller parts and glued together. So that means nonlinear. And for me, this GStreamer editing service is a really powerful tool, not a bit badly documented and very complex. That's why this dragon is here. Before we go to the examples of the pipelines written in a programmatic way, it's also important to talk about the states of the pipeline. So pipeline can be in 4 different states, and transition, it's not, and the pipeline transition from one state to another is in order always. So there is basic state is null, means that this is the initial state of the pipeline. Nothing is working there yet. And from the null, the pipeline may go to the ready state only. And being in the ready state means that some kind of basic checks are already done. Some hardware is already accessed, checked, instantiated, and so on. Being in a ready state means that the pipeline can go into the paused state, and when being in the paused state means that the paths, sink and source paths of the elements are activated, the capabilities are negotiated, and the pre-rolling is done, if possible. Pre-rolling means that just to save time of the pipeline, it means that the pipeline in paused state is filled, all of the elements are filled with one buffer. So in other words, so the one final buffer is already in the very downstream element, ready to be passed to the user, more or less. And from the pause state, this pipeline may go to the playing state where the data is flowing, and being the pipeline in the playing state, so everything is working as you would expect. And there is also when you stop the pipeline, the state transition goes in the opposite direction. So from the playing to paused, data stops flowing. From paused to ready, so paths are deactivated, and negotiated capabilities are just forgotten, and from the ready state to null, so the devices are closed, some kind of resources are released, and the internal state is reset. And this is the first Hello World application written with GStreamer using its interfaces. At the bottom, there is a CLI pipeline, which is an equivalent of that code. This is C code. GStreamer is written in C as the core technology. And this, I haven't modified that because I just took it from the internet. Usually when I work with GStreamer, I use C++. So what it does, first of all, it needs to initialize the GStreamer in line number 10. And here is the something I mentioned, that you may parse the CLI, the text representation of your pipeline in the code and decorate that. So there is a parsing of that part of the pipeline that you would execute with GST launch. And having that pipeline parsed, you may just start playing that by setting the state to the playing. And then you need to wait for the pipeline to finish. So you are basically asking the bus of the pipeline to wait for the either error or end of stream message. whenever you receive that, you just exit the application, and you need to, because it's C, so you need to free the resources allocated before. Another example of that is the next level of working with the GStreamer in a programmatic way. This is the pipeline at the top. This is the video test source producing some kind of uncompressed video, and this video test source is linked with the auto video sync, which just renders the video. So similar as before, we are initializing the GStreamer, and then we are creating these elements, video test source and auto video sync. So this is like kind of factory functions creating the elements. You create the element by providing the name, and you may the type of the element, and you may also provide some kind of meaningful name to that. For the video test source, the meaningful name here is source. For audio video sync, the meaningful name is sync. This is, if you just generate the graphics pipeline, these names will be there. And then you create the pipeline, and you add this element to the pipeline in line number 26. And then once the pipeline is aware of these elements, you need to link them correctly. So in line number 27, there is this GST element link, which links source element to sync, which means that it links video test source to audio video sync. And also line number 34, it modifies some property of the video test source. The property is called pattern, and this pattern is set here to value 0, which means that pattern number 0 will be used as in the produced video. Then line number 37 sets the pipeline to playing, so everything starts working, data is flowing there, and then in line number 45 you get the bus, and line number 46 you just wait for either error or the end of stream, whatever first, and then process that message. If there is GST bus time pop filtered, line number 46. This is a blocking operation, so it lasts. The thread is blocked as long as the pipeline is playing that, and some error handling and freeing resources. Yeah, that's it. So there, I would recommend, if you would like to learn more about GStreamer, I would recommend to go through tutorials. There are about 10 or perhaps more tutorials going to more advanced stuff there, how to work with the code being programmatically, how to work with the dynamic pipelines, how to work with the probes, so how to register these callbacks to sniff the content of the data flowing through the paths. They are well defined, well structured, and documented, I would say. So this is a slide about my subjective opinion of GStreamer. I have a kind of 5 years experience of working with it. I started using that for a project. I wanted to stream the video from the RGBD camera to the browser because I wanted to build some kind of UI for my application, and I thought that the only one valid tool for writing UI should be a browser. So I wanted to stream the video, but I didn't know why, so I didn't know how, so I started to learn about GStreamer and about WebRTC, and finally that was my first project when I learned a lot about GStreamer, about the concepts and so on, to stream the video to the browser from local computer to browser, but using the WebRTC stream. So the library, the framework is written in C as the core technology. So this is the all pure C, weak, simple. So you cannot, you know what C is, so you know what you can achieve. You can achieve everything, but you need to write that manually. So there is a lot of in the code places when you see how something is done, but you don't understand why. So you don't understand the concept. For me, this is a kind of drawback. I mean, this is the, not something that I very like. That this is a C interface. And another thing is that because they started to write in C interface, they started to invent the wheel. So glib and gobject. So there is a concept of classes, a concept of C++ classes, but written again in C. So this is something that they use from glib. Nightmare, in my opinion. They could avoid doing that using C++. I was talking to the community about that, and they started in 99. So C++ in 1999 was totally different than what we have now. And it was even, the problem also was with the ABI stability. So they decided that they would like to stick to C and continue with C. But nowadays, they provided the Rust binding, and all the new development in GStreamer, all of the new components they write, new elements they write, everything is written in Rust. They also rewrite some parts of GStreamer in Rust, and they are really happy about that. I don't have any particular experience here, so hard to say how fun is it, but probably it is. And also, the problem with the C and with the resources and with the multimedia platforms is that we don't want to waste the memory. We would like to save as much resources as possible, and the interfaces are heavy ref count. They use a lot of heavy ref counting in the interfaces there. So you need to deal with the releasing stuff, and you need to understand when you don't need any longer. So nothing helps you there because this is C. In my opinion, the entry threshold is very high. So you need to spend a lot of time analyzing, and even the tutorials and the documentation only touches the basic concepts. The more advanced stuff is something that you start thinking that you understand after long hours working with the problem. But still, the positive part of that is that this is open source, so you may always take a look into the code and try to understand what is going on there. I would say that from the, let's say, technical perspective, the code is written in a decent way, but it is C. So, as I said, the lack of tutorials for more complex topics, because documentation is good, but the true value is the tutorials. If you are new to this world, I would say, and there is almost no documentation for the plugin writers. So so far we were using here in this presentation GStreamer from the application perspective. So we were writing the final application, working running the pipeline, but you may also develop your own plugin or your own element doing something, and there is no decent documentation about how to do it. The only one way how to do it is to analyze a similar type of element that I would like to write, analyze the code, and write something similar. That's the only one way, and recommended by the guys working with GStreamer a lot. This is open source, so when you take a look into the code, you understand what is going on there because this is C, but you don't know why, because it's not documented or there are no tutorials. So that's a problem for me. And also, it requires that you understand this more advanced topics. It would help you analyze the code and knowing why something is going there. And this GStreamer editing services is, as I mentioned, the wrappers or some kind of layer built on top of GStreamer. It is huge, it is complex, and also not very good documented. This is C, so you need to manage the resources manually, which is error prone. This is C, so there are exits and go to. Yeah, sorry, you cannot use exits. You need to use goto. At least they do a lot. So this is C. So when you write a C++ code, you need to be aware of exceptions and handle everything properly. And that's something that we C++ people shouldn't care about, and we like not to care about. And we have the tools that helps us to achieve something like that. And when I write some pipelines, as I mentioned, I usually use C++, and I usually have some kind of wrappers built on top of the C functions to just to help me and not to make a mistake. So the most common, the basic stuff that I use is the array. I skip that because you know everything about that already. And usually I use a unique pointer because this is something that works pretty well with GStreamer because everything is a pointer in GStreamer, and there is a lot, let's say, resource acquisition and resource release functions. So with the unique pointer, I can use unique pointer with the custom deleter because there is every type of the resource has a dedicated function which needs to be called to release that resource. The signature is very similar. There is just the pointer to the resource, but just the name is different. So I was thinking how to handle that automatically using unique pointer. This is a kind of elaboration. What are the possibilities there? You know all of that already, I think. So unique pointer with the custom deleter, it is possible to use it. So you may define the, as an example, I'm using GST caps. This is a kind of C structure which contains information about the capabilities, and there is a function which can generate you the capabilities from string. For example, in line number 18, there is a audio raw audio with the sample rate 44,000. This kind of string could be parsed and represented by GST caps object. And the problem is that this caps from string gives you the result for the ownership. So you need to be aware that you need to release that resource once you don't need it. So with unique pointer and custom deleter, you can achieve something like that, like in line number 10. So you declare the signature of the custom deleter and you pass the name of the function, which is also a pointer to the function. And this function will be called once the lifetime ends of the unique pointer, or once you explicitly release that. That's something that we know. But still, this is ugly, this is long and error prone. Because why error prone? Because you may always pass some other function which has similar signature, and compiler won't warn you. So I was talking about that recently on GStreamer conference with guys from WebKit, and they told me that they have something like some custom wrappers there as well, and pointed me to that place in GitHub. So I analyzed that, and still looks scary, looks long and ugly. So there is a custom implementation of the unique pointer with custom deleter and a set of macros which generates the custom deleter as a class, as a structure, as a functor, and that the functor calls the appropriate function underneath. And as I said, this is ugly, long, and still error prone. And I invented, perhaps, I'm not sure whether I invented that. I came up with my way of doing things, something like that. So I use C++17 and non-time template parameters declared with auto. And with that feature, we can achieve the same with just 2 lines of the code. So there is a function object which is known at compile time in line number 6, and in line number 9, I'm passing that function object to the unique pointer as a custom deleter, and the line number 13 and 15 is an example how this type is bound to the function which releases the resource. So this is known at the compile time. It's not possible to change the signature at real time. I mean, it's not possible to pass. Still is, but the function which release the resources is passed at the compile time. So you don't need to do it. You don't do any mistakes related to that, and it's short, just 2 lines of code, and do the work. And the final summary about the GStreamer. So I think that GStreamer is a really great framework. It is really, you can achieve everything that you would like to do with the multimedia so far, at least in my experience. It is complex. The entry threshold is high, but there is a community which tries to help you. So until recently, they were using IRC as the communicating channel. It didn't work well. There was also some kind of Google mailing list, but no responses for long days, I think. And recently they established a Matrix server, and they are really active there. You may find all the experts there. They work for just a couple of companies which are experts in providing the GStreamer solutions. They offer paid support, but also they tries to help you in their work time. That's established and works pretty well. So you just need to know what to ask about and be patient, because they work on paid projects as well, apart from trying to help the others. And what they do, they upstream work to the repository while working on this projects, paid projects, which is good, which is great. And GStreamer is evolving. New features are being developed. This multimedia industry goes pretty fast, and GStreamer tries to follow very closely. For example, recently they improved the WebRTC implementation, and it's really easy to use WebRTC with GStreamer to stream your video between browsers. That's something that didn't exist 5 years ago when I started. All the big players use GStreamer, writes custom components, which when you work with, let's say, professional cameras for example, for automotive industry, using GStreamer plus NVIDIA hardware is, let's say, something typical. So it's important to understand the GStreamer concepts and basics and how to work with that. And I think that's the end of my presentation. If you have any questions, please ask. And thank you very much.
So waiting for the questions. For sure, I will have a couple of those. Maybe starting from the end. So with your approach to manage the memory and memory resource management, you are using the integral constant here. Any reason for that, and not using directly the type itself?
Because if I'm passing for example, in line number 13, I'm passing the function here. Yes. Mm-hmm. And with this integral constant, it allows me to define it once only, and not to pass when I create the unique pointer object. Mm-hmm. Without, you would need to declare. That's the slide before, I think, here. So without that, I'm in the line number 10. Whenever I create a unique pointer object, I need to pass that function at the end.
Okay, so you are using just the default constructed the object here, and which is the function pointer in the end. Okay, and just a side note, like non-type template parameters work good with the function pointers, but lambda without the capture list, and so if you guys will try that out with the lambdas with the capture list, it won't work. So just a side note, with like C APIs, it will work like a magic as you presented. So just a side note, and I agree with you that the WebKit approach is not good. So,
that was my impression as well.
That's the correct way of doing things. It is my personal opinion about it.
Thank you very much.
And guys, if you have questions, go ahead. Tomasz will most probably answer that. And I will continue with my questions, waiting for your questions. Like you mentioned about the GStreamer's editing services, and any hints if anyone would like to try it out, where to look for those?
I would suggest to read the existing tests and existing examples in the GitHub or the GitLab repository. There are some basic concepts. There is also a PTV video editor, which has been created, I think, more than 10 years ago, and that was the, let's say, first motivation of writing the GStreamer editing services. This PTV video editor is written purely with GES, but there are Python bindings on top of that. So PTV video editor is written in Python, which is Python bindings of GES. So still this editor is not very stable, but you may get familiar with that to understand what are the possibilities.
Okay. Yeah, thank you.
So unit tests, existing examples in the GitLab, plus this PTV, just to play with it to understand what are the features.
Okay. And you've been mentioning about the probes, and I've been wondering, because I'm currently in automotive business, and I know you might be aware of the functional safety issues, and the common issue when you are implementing HMI with functional safety requirements is that there is a kind of a feature like rear view camera or any use of the camera that needs to be safe, and there's always a feature that needs to somehow recognize that there is a stall on the camera, like camera freeze or something. And that is probes a proper way of achieving that, or is it just for the like debugging purposes and not the something like that?
By camera freeze, you mean that there are no frames coming in?
Yeah. So like when you are like going backwards with the car and you are using the rear view camera, you would like to be sure that nobody enters your path, right? Like a pedestrian or something. And the common like risk there is that you will have a camera freeze or something, that no more frames will reach your view, right?
So that when you could register your callback and, for example, analyze the position timestamps of the incoming of the flying buffers there, and you would notice that there is no new buffer in some time window, and
the probes will serve the purpose here.
Yeah, of detecting something like that. Yes.
Okay.
Yes. If you are using app source, that's something that is here. You may also detect it there because that's you who inject the data there, but probably you have a dedicated element which talks to your camera. So this is a black box. So yeah, prop would be okay.
Okay.
Everything you may achieve by writing your custom element, but yeah, it's not simple. It's complicated. So
Okay.
I would say that prop would be the good place for detecting something like that.
Okay. Maybe one last question from my side. I've noticed like when I've been playing with the GStreamer some time ago, it like there's like always a 1.0 version around, and is it like normal thing, or is it just a coincidence that there's like GStreamer version 1 everywhere?
I think that they changed the they broke the interface at some point, and
Okay.
before it was 0.1.0 probably, or 0.10, I don't remember, and then they changed to 1.0, but it's not just one version of GStreamer. I mean, perhaps they versioning ABI something like with that. I don't know, but they produce releases all the time, every couple of months. And
Okay.
the release version changes, but always there is 1.0.
Okay.
That name of the utilities.
Okay. No questions coming from the audience. You guys have a last chance probably. And I was surprised that you mentioned about the Netflix that they are using that. I was like not aware that the tool itself is so popular that there's easy.
It is more and more. Even they upstreamed recently very nice feature. I mean, Netflix guys, they invented a better way of splitting pipeline into multiple processes without copying data between.
Nice.
So there is it will be in the upcoming 1.25 or 26 release, I think, of GStreamer. So you may, if you have kind of part of the pipeline which is not very stable for some reason, because you are using third party and sometimes it crash, you may divide that pipeline into stable part and unstable part, and for example, restart that unstable if that would work for you.
Yeah, really
And
cool.
I think that they invented that because they have some similar issues.
Some issues, yeah. That's always a good reason to implement something. Yeah. Okay. And like for sure, guys, if you are playing with the Qt library, you most probably are aware that the like all the multimedia stuff is like going through the GStreamer. So if you want to like do something more fancy with the Qt and the multimedia, you always end up with playing with the GStreamer. So yeah. So that's good to know, and for sure we are like struggling because we are porting the Qt for other platforms as well, and for sure some platforms does not support GStreamer, and I've been wondering how hard it is, to port something like that to like the platform that is not supporting that. But now I understand that most probably it will end up with implementing some element based on some other element which is close enough to it.
Yes, there is also probably there is also very interesting activity in GStreamer community. They, as I mentioned, so far GStreamer plugins is a set of dynamic libraries, and they are experimenting with cross-compiling to WebAssembly everything. So for now they limit number of elements, but something is working there. It's really slow for now, but there are some kind of light in the tunnel already. They would like to, whatever you want to, you are able to do with the C code. They would like to do it in the web browser in JavaScript, for example. So you just load the WASM file, and you have all of the interfaces bound to the JavaScript, and you can define your pipeline in the web browser and have the multimedia being processed, the pipeline working in the browser memory.
Really interesting tool, and like I see now that it's like more popular than I expected, to be honest. But,
in automotive, as I said, I have experience in working with the remote control cars. I was doing some video processing there. So NVIDIA hardware Jetson or Orin right now, plus automotive industry grade cameras, plus custom GStreamer elements wrapping some kind of encoders, basically NVIDIA API of their encoders, exposing video to the rest of the pipeline in a usual way. That's something that it's typical in this industry, I would say.
Yeah. Good.
Yeah.
Good. I guess we go so into the detail that nobody is encouraged to ask a question. Okay. So thank you, Tomasz. Most probably. So guys, I shared the link to the Google Forms. If you can share the feedback with Tomasz about his presentation, he would appreciate it. Me as well. And please share also the information if you would like to have more talks like that. Maybe you have some other tools or libraries that you are using within your company or your industry and you would like to hear more. I can reach other experts like Tomasz in the area of your interest. So yeah. And there is a prompt feedback. Thank you, Tomek.
You're welcome.
Yeah, I really appreciate, Tomasz, that you find time for sharing all your expertise. I recall when one of my colleagues from company was struggling with GStreamer, and for sure he would love to see that presentation up front. He's fighting. And and thank you for sharing all the tools that you are using to to debug it or inspect the pipeline. So I think that's really awesome. And thanks again.
Yeah,
maybe one last thing.
I'm fighting every day still.
Yeah, but it's like I hope it's a good fight. So one last thing, I think I will just share that with everybody. So Tomasz mentioned that already, but I maybe do it like more openly. So as you know, that Tomasz is playing with his colleagues. He have his own band. So they just released the new song. I'm shared the link on the comments. So yeah, go there, listen to it. I don't know, Tomasz, how you would like to promote the video, like any likes or whatever. Do you want it? Just have a moment for your advertisement.
I don't know. Just fun, just hobby. I don't have any expectations. But
yeah, so guys, go there and like it, share it with your friends, whatever you think appropriate, and for sure, I think it's good. So I like it, Tomek. So yeah, I can promote it with ease now. Okay.
Thank you.
So thank you everyone for joining. Tomasz, once again, thank you for sharing your expertise, and yeah, have a good rest of the day. Yes, like the day is end already, but nevertheless, thank you guys, and yeah,
thank you.
See you
have a good evening.
Month, probably. Bye.
Bye.